All right, so I'm going to pick up from where I left off last time. Um, and as always, if you have a question, just stop me. And you could just unmute. Um, and my hope is that you did get a chance to look over the video I did last week. But if you didn't, I just want you to know, and please share share that this is I always will. I'm recording these and I'll upload them to YouTube. I created a specific channel playlist for this semester, so it'll be 23 Fall Boyce 110. So right now in that playlist, there's only one review. I'm also doing Allegheny campus reviews. They're slightly different in some of their questions, but it's pretty much a similar format. So you can always look at those. I do those from 3:15 to 4. So you'll be able to look at those if you want some extra, kind of extra review time, or if that's a time that works better for you, you're certainly welcome to attend those, but they'll be more specifically geared towards the way that the Allegheny campus test is formatted. There's some nuance, but we'll get into that. So in the OneDrive folder, I created this document called 23 Fall Boyce 110 Review. Last time I discussed the mechanics of the test. 25 questions, you have 1 hour to complete. They're going to give you a calculator. You have 2 attempts to get a 92% or better, which means you need to get 23 out of 25 questions in order to pass, and then continue with 110. I did some practice problems for the first couple questions, like the metric system, converting, things. We're going to do a little bit more practice of that here in just a minute. But that's what, if you go down the file, like I said, which is in the OneDrive folder, you'll be able to see the same things I'm using and use it as a key. My intention is to give you guys, or to try and reformat the practice test or the practice set of questions. That way you can kind of do this. But what I'm trying to model here is something that a previous Boyce student did that I thought was a really good idea. She took all the blueprint questions and basically just, said, okay, there's going to be 5 questions. And then what she did is she sought after five questions that would fit into this category of converting metric to household to metric. And so there's lots of examples of that online. There's lots of examples even in a lot of my content. And like I said, I'll try and give you lots of examples of that as well. But that's what you want to do, is make sure you're kind of practicing a variety of those, with these being the common conversions for particularly liquids that you're going to see. I don't know that you're going to see going from like inches to centimeters, feet to meters. I don't know that, but if your instructors tell you that you are required for that, then just, you want to make sure you know that. I have not seen that on a test before, but I've also not seen Boyce exams either. So I have no idea if they want you to know how to convert inches to centimeters and things like that. I do know that we don't do that at Allegheny campus, so that's why I don't spend too much time on that. But you might see something like that on a ATI or something like that. So I should also add that if you have questions that you come across on ATI, and you're able to screenshot it and send it to me, or just copy it and send it to me, I'll be happy to answer questions you might have about those. We'll also practice doing metric to metric conversions. So like going from like grams to milligrams, milligrams to micrograms, and vice versa, liters to milliliters, milliliters to cubic centimeters. Technically this kilograms to pounds should be up here, but in the blueprint it writes pounds to kilograms, but technically that's a household to metric conversion, but that's okay. And like I said, I've never seen these conversions done in a at least in a nursing dosage calc situation. And the joking example I always give is like when you hear about medications or drugs and kilograms, you're usually thinking like marijuana, cocaine, like things that like someone got seized having like half a kilo of whatever the illicit substance was. So we don't deal too much with that. All right. So now I wanted to get into the new stuff here, and I added some additional questions for these things. So one of the things you'll see is, as far as a intake output calculation, the question you'll typically see is they're going to give you a menu of foods that the patient consumed in a hospital setting, and then you're going to calculate how much volume they consumed. Now, in order to do this, you need to know your conversions. So that's where practicing your household to metric conversions will be helpful. You also need to know what you're looking for, because this is how you'll see it. It'll say calculate the fluid intake for the following meal. It'll give you some details, like if it tells you a glass, 8 ounces, like here it tells you they had half glass orange juice, so you can make some assumptions based off of that. And then it just tells you total fluid intake. But the thing is, you need to know that when they mention total fluid intake, and when we're talking about in a clinical setting, we're talking about how many milliliters did they consume. So it's important to know that. All right. So let's do some calculations. I know that if you haven't been practicing this isn't going to be something that's like right off the bat for you easy. So that's why we're doing these things, just as additional practice. So let's look at each line. So a half glass of orange juice is a liquid. A glass is 8 ounces. So a half glass would be 4 ounces. What I'm going to do then is I'm going to convert that to milliliters. Now I'm going to write this out like using dimensional analysis, but then I'm also going to just shorthand this in a second. But one of the things you need to know is how many ounces are in a milliliter, how many milliliters are in an ounce. So in 1 ounce, there's actually 30 milliliters. And you can verify that by looking at your, in your kitchen, you probably have something that measures milliliters to ounces, and you can confirm that 4 ounces, which is half a cup, will also give you 30 milliliters. So basically, anytime I convert ounces to milliliters, I'm going to multiply by 30. But if you like to see dimensional analysis, or at least if you get stuck, like, am I multiplying or dividing, this is a good way to kind of practice that. So 4 times 30 is 120 milliliters. So from here on out, I'm not going to write out the dimensional analysis. I'm just going to write out just straight up 6 ounces times 30. And this is technically milliliters per ounce. So that's 180 milliliters. Turkey sandwich is a solid, so we don't worry about finding a liquid component of that. Now, there is some things, and I haven't found a good resource on this yet. I keep telling myself I'm going to find this, like Jello versus pudding versus ice cream, like what's technically a liquid, what's technically a solid. I don't know all the details on that. So if there's a list that exists, I'll ask, send it to me. But if not, you want to confirm with your instructor what are some potential, like, I would even ask the question, like, what are some potential like things that could show up that we might think is a liquid that's not, and they might tell you things like, oh, gel or pudding, custard, or ice cream. How would you think about that? I think of ice cream as, it's ice cream. It's solid when you're enjoying it, but if you let it sit there long enough, it becomes a liquid. So what is it? Does it contribute to your your ability to produce urine with ice cream? My guess is not, because of the protein and fat content, but I don't know that definitively. Jello is predominantly a liquid dessert. It's just that it's, we add in the gelatin to solidify it. And then the clue I always think of, and I could be completely wrong about this, but I usually look at the clue that it gives me the ounces That could be a weight ounce, but I'm assuming it's a liquid ounce. So I am going to go ahead and just calculate that 2.5 ounces, convert that to milliliters. Sorry, 30 mil per ounce. So I think that's going to give me, so 30 times 2.5 is 75. And then a half pint of chocolate milk. I mean, isn't chocolate milk just chocolate ice cream melted? But that's where that's where I have a hard time. So a half pint is the same thing as 1 cup, which is the same thing as 8 ounces. And again, you might be wondering, like, well, how do I know that so quickly? It's because I have these things memorized, right? So 1 cup is 8 ounces, it's 240 milliliters. A pint is 2 cups, so a half pint would be 1 cup. Again, these are things you have to know off the top of your head when you are doing these things. So 1 cup is 8 ounces, which is 240 milliliters. Then all I'm going to do to solve this type of problem is I'm going to add up my volumes. So I'm going to have, I already have my calculator, 75 plus 120 plus 180 plus 240. And I'm going to get a total volume intake in this meal of 615 milliliters. So they got more than half a liter of liquid in this particular meal, assuming that I'm right about the Jell-O being a liquid. So you'll see a question like this. There's varieties of things. If you just type in to like do a Google search, calculate the fluid intake for the following meal, like you should be able to find several questions that fit that category. And there should be, even if you have like a textbook or, like a dosage calc textbook, there should be some examples of that as well in there. So the thing, like I said, that I'm always hesitant on and telling you is I don't know with 100% accuracy whether or not you are going to see or be able to know and differentiate between like custard, pudding, Jell-O, ice cream, things like that, ice chips. There's some nuance there that I'm just not 100% certain on. But okay. All right. And there'll be 2 questions that usually it's back to back. Calculate the fluid intake of the following meal for option 1, or question 1, and then question 2, another meal situation. All right, these are probably the ones that I think nursing students get right the most, because you have some familiarity with oral medications. You have some familiarity with the oral medications because it is going to be utilizing just your basic 1-step converting things. And you've done this most likely at some point in your lifetime, or if you have kids, you've given your kids medications, or if you take supplements, you take 1, you take 2, you take 1 3 times a day, you take 2 4 times a day, 1 time a day, whatever the case may be. You have some idea of like what they're asking you here. Now, some of the things you may not be familiar with yet is some of the things like what PO and BID stands for. You will see that over time, understanding what those terms mean, but sometimes it might be helpful. And I think I do have a document that explains all these different definitions. That way you can reference it and you can see what each of these things mean. So like PO stands for per oral, meaning that this medication is going to be given by mouth. That's why these are oral medications. And oral medications are either going to be tablets, capsules, caplets, or it could be an oral suspension. So there's 2 ways that might be delivered. So in this question here, it tells us to calculate the dosage if I'm ordered Xanax 0.5 milligrams by mouth, and then we have this BID. BID stands for twice a day, okay? If it said T as in Tom, TID would be 3 times a day. If it said QD, like the letter Q and the letter D, QD means daily. So there's a bunch of different shorthand abbreviations that you're going to need to be familiar with when you are preparing and studying for this. And if you ever are taking a practice question or going through ATI and you miss a question, a lot of times it's because you may have misinterpreted the BID, the TID, the QD, whatever that happens to be. I don't know when or if or how much you learn those different abbreviations, but you're expected to know them for your dosage calculation test. All right. So the order is 0.5 milligrams by mouth twice a day. And then we have a label that indicates are available. Now, sometimes you'll see a label. Sometimes they'll just tell you the available is, what it is. So I always like to highlight what we're looking at. There's a lot of information on a label. Probably the most important thing is, do we have the right medication, right? So it says the order is Xanax, so we want to make sure we're giving them Xanax. It tells us it's available in a tablet form. Okay, so that's important to know, as opposed to capsules or some sort of oral suspension. It tells us that the whole bottle, that there are 100 tablets in the whole bottle. We don't need that from a calculation standpoint. That just tells us how many we have available to utilize, or maybe we just need to open up a new bottle. Okay. The reason I mention that is because we never want to assume that we're going to give someone like an entire bottle, 100 tablets of something like Xanax. Okay. Probably would be, I'm assuming it would kill somebody doing that. I don't know what the, what Xanax technically does to the body, other than I know obviously it's an anti-anxiety medication, but I don't know like if you overdosed on it, what that would happen. But you would know, hopefully commonsensically, that you're not going to give someone 100 tablets in one sitting. The other thing that's important is what is the strength or the available dosage strength of each tablet. And that's where that big number comes in, that 0.25 milligrams. So that tells you, and tells me, and tells the pharmacy, and tells the doctor and whomever's administering it, what the strength is of that particular medication. So when we're solving the math part, we just have to make sure we can utilize the information from the label, and then we just put it into our calculation. So if I'm doing dimensional analysis, one way I might do this is, my preference is I always start with what I'm ordered. Okay. I'll take my 0.5 milligrams. Sometimes I'll put it over 1. And then I will do my best to convert milligrams to the way it's going to be administered. So here it's going to be administered as tablets. So one tablet has 0.25 milligrams. And before I do any kind of calculation, we can see that we're left with tablets, which is what technically we're looking for, because I want to know how many to give them. Think about, we're giving this to a person. You can't say, here, take 0.5 milligrams. They don't know what you're talking about. You're going to say, take 2 tablets, right? You're going to hand them the cup, and then 0.5 divided by 0.25 is 2. So you're giving them 2 tablets. And then the question will say, how much medication will your patient receive in one dose? You'd write 2 tablets. If it asked you how many how many tablets they would receive in a day, that's where you have to pay attention to this BID, right? So you are going to give them, if it's twice a day, you're going to give them 2 tablets twice a day. So you would actually give them 4 tablets if it asked you what the daily dosage would be. A lot of times you care about the daily dosage just to make sure you're giving the pharmacy is giving the patient enough medication to last whatever it's going to be, 10 days, 30 days, whatever the case may be. The other way to solve this type of question is what I think is the common thing, is just doing what's called ordered over available. So my order is what? 0.5 milligrams. My available is 0.25 milligrams. Now, ordered over available is a great one to know, but don't forget your quantity. So 1 tablet is my quantity. And I'm going to get to the same answer, the 2 tablets. Okay. So the big thing that differentiates these, and one of the things that's helpful, is if you do a Google search for medication labels and just look at the different types of medication labels, you will see a variety of the ways that these things. So Xanax doesn't just come as 0.25 milligram tablets. It might be 0.5 milligram, tablets. There might be, 0.125 milligram tablets. There's a whole variety of things that could exist depending on what's available and in a given situation. Later on, like next semester, this will be restated as 500 micrograms, and then the available will still be the same. And you need to know that either 500 micrograms is the same thing as 0.5 milligrams, or you're going to have to do a 2-step process where you convert milligrams or micrograms to milligrams and then do your calculation based off of that. All right. Now, I made the mistake. I chose the wrong example. This would actually be another example of an oral-based medication, but I'm going to leave this here because I'm going to try and give you some details that will pertain, even though it's not technically an injectable. Oral medications, oral suspensions are going to be treated the same way as far as math is concerned as your subcutaneous and your intramuscular routes. What does subcutaneous and intramuscular mean? It means it's being injected. And if it's being injected, that automatically tells you that you're looking for milliliters. Okay. If it's being injected, the only thing you can inject is going to be a liquid volume in milliliters. Okay. Now, could you give someone microliters or liters? Maybe, but I've never seen it as an example question. So I'm assuming that we're probably not going to be dealing with that. You can give someone really, really small milliliters, or you can give someone a big amount of milliliters. It just depends on what it is that we're talking about. But the approach to this is going to be exactly the same, and you're going to see this very similarly, whether we're talking about an oral-based suspension medication, which this is, even says it in the listing or in the label, oral suspension, or if it's an injectable. So we're going to look at this and we're going to see we're going to look for a couple things. We want to first of all make sure we're using the right medication. So it's Aldamet. Then it says your patient is ordered, and then you can see 600 milligrams by mouth TID. TID tells you it's 3 times per day. That may or may not be important. And in this instance, it's not important because it just says how much would we administer in 1 dose. So what's our available? So our label is our available, right? This tells me that it's an oral suspension and that there's 473 milliliters available to us, but we don't use that for any kind of math or calculation. What I'm looking for is right down here, the 250 milligrams per 5 ml. Because I want to know, remember, think about you're giving this to your patient. Your patient is either going to swallow a pill, drink a liquid, or receive an injection. And sometimes that injection is just going in through the IV port. So how are these things being administered? Okay. And then what is important for that administration? If you tell them milligrams, that doesn't say anything. What you want to know is what the liquid equivalent of that is. And this is why we're doing these things. So when we're talking about oral suspensions, subcutaneous, intramuscular, and even IV, we care about milliliters. Milliliters is kind of like your tablets or your capsules. So let's solve for this. I'll do it two ways, right? So I'll start off with the dimensional analysis way, 600 milligrams. And I want to convert milligrams to milliliters. That's the other thing. You know, your question says how much medication will the patient receive in one dose? You need to know that it's milliliters because it's an oral suspension or it's an injectable. Oral suspension, injectable, you're going to be solving for milliliters. Now, here it tells me that, or if I look at my available, I have 250 milligrams per 5 ml. And then what I'm going to do is I'm going to take 600 times 5, which gives me 3,000, divided by 250. And I'm going to give the patient 12 milliliters. If you prefer using ordered over available, what is my order? 600 milligrams. What do I have available? 250 milligrams. Now, this is where a lot of students go wrong. This is why it's important. What is your quantity? Your quantity is 5 milliliters. You don't have to put it over 1, but just make sure you have your quantity. Sometimes you get, you answer these questions correctly, and it's by accident because it's just 250 milligrams per ml. So you're just multiplying by 1 anyways. You don't need to worry about it. But you got to remember, if you're doing ordered over have, you got to remember to account for your quantity. Okay. And you're going to get the same answer, 12 milliliters. So remember to incorporate your milliliters into your, incorporate your quantity if you are using ordered over have or desired over have, ordered over available. Just make sure you also account for the quantity, so you don't miss that type of question. I'm going to come back to this reconstitution question because it's going to take me a little bit longer to explain than I have time for today. But I will discuss this at the next time we get together. So I'm going to come back to that. The last one I wanted to do is your sliding scale. So with insulin, you're going to do two things. You're going to probably combine two types of insulin and then just add the two insulins together. And then I think a lot of times you're also going to be marking these on a syringe. So that's one thing. So it's as simple as, like, let's say, I have regular insulin and then Humulin N or NPH insulin. I might have 20 units of one, 30 units of the other. You add them together, 50 units total, mark it on the syringe if a syringe is there for you to mark, or if it tells you to mark. So it's as simple as adding them together. And like I said, we'll look at some examples in the next week and the week after. My hope is that in 2 weeks I'll be able to go through with you I think it's 2 weeks. Let me check here. Oh no, I guess it would be next week. Next week is to go through like a little bit more of a detailed review, because the week after that is your actual test. Okay, so if you're in crunch time, just know you have a test in 2 weeks on this stuff. For the sliding scale, this is just a matter of, can you read the order, and then can you write that answer down? So let's just say I'm going to change this number. Let's just say 365 this time. So we look at the patient's blood sugar. At noon, it's 365. Then I'm going to look at my different levels. So if it's less than 70, if it's 70 to 200, if it's 200 to 250, then we look for the 365 range. Notice it's way up here, right? So what are we going to do? We're going to give them 10 units of regular insulin. And then that's what you would write in your thing here, is 10 units. Now, I think where some students get this one wrong, other than just trying to be quick and answer the question, they'll look at this here and they'll see, oh, okay, regular insulin, 100 units per milliliter. and then you start trying to do some conversions. Don't do that. And the reason you don't do that is because insulin is measured in units. You have what are called unit syringes, and that's the unit that you're giving them. So two things that are commonly measured in units: heparin and insulin. Okay. So if you don't know any diabetics, or you've never met somebody that deals with insulin, they're not calculating out how many milliliters to administer. They're calculating their injections are going to be based off of how many units of insulin they need. So if they need 10 units, they'll have a syringe that'll account for and tell you that it's 10 units. The reason I'm also telling you this is when you look at the actual test, when you see this, one of the things you're going to see actually is that the syringe that they'll ask you to mark will have units listed. So if you're converting units to milliliters, you're just getting ahead of yourself. We kind of stay away from that when we talk about insulin. Insulin is measured in units. So, okay. So I know I went over that kind of quick and fast. My hope is that you go back, watch, the review, slow it down, stop, review the things that I may have gone over quickly. And then, obviously ask questions. Do you have any questions before we kind of wrap up here, Bria?
Yeah, I do have a question. I didn't know if you was going to still record it or not.
I can pause. Yeah, I'll go ahead and stop now. So,
All right, thanks.
mhm.